So welcome to Bigelow. This is our first Café Sci that is in person in 3 years. So we are thrilled. Thrilled to have everybody here. My name's Debbie Bronk, and I am just incredibly grateful that I can say that I'm the president and CEO of this amazing laboratory. Bigelow Laboratory is an independent research lab. We were formed back in 1974, so we're going to be celebrating a very big birthday in a couple of years, which we are thrilled about. We are known for the work that we do at the base of the ocean food web, right? So the microbes, which is not the most popular type of organism at the end of a pandemic, but you're supposed to laugh at that. And there's this awkward silence. But our microbes are good. I mean, they're really the foundation of all life on our planet. And we study those organisms through just basic discovery-based science. We try to inspire the next generation of ocean leaders through our education programs, all the way from K through 12, well, actually high school, all the way through professional workforce development courses. And then our more solutions-oriented work that we do. And some of that we're going to be focused on in some of our later talks. So as a nonprofit research institute, I want to thank any taxpayers in the room, because much of our work is funded through federal agencies and state agencies. So thank you very much for that support. We try to be very, very good stewards of that money. We're very grateful to have it, and this is a scrappy place, so we make it go as far as we can. And we are also very grateful, and Stephen is probably, I worked with her so often, and she still didn't forward the slide, which is not working. So while Joe forwards the slide, it's not moving forward. Okay, thanks. Okay. So what was I just about to say? So thank you to the taxpayers. And also, we would not be able to do the work that we do. We wouldn't be able to be in this incredibly energy efficient, effective, state-of-the-art laboratory which makes so much of the work that we do possible if it wasn't for all of our donors and supporters, many of which are in the room. So thank you very much for that. And let's give them a big round of applause. And then finally, we rely heavily on our board and advisory board, because as we're not that big of a laboratory, and so we need a lot of expertise that we may not be able to afford to have in-house. And so if we have any board members or advisory board members, could you briefly stand for a minute, because we want to acknowledge who you are. Thank you, thank you. And one of the people we really have to thank is every year, HM Payson sponsors these Café Scis, and they're one of the ways that we work really hard to try to get our science out into the world. And today we are excited because we're going to talk about the partnerships we have with artists. So if you're doing basic research, you're doing something that's very similar to art, right? You're trying to create something that was not there before. And to do that, you need to be inspired, right? It's very hard to say, oh, I'm going to discover something amazing today. You need to be inspired to do that. So our partnerships with artists grow very organically. Artists reach out to us, and if there's any way we can help them or accommodate them or work with them, we try to. Stephen Profizer, who is right behind me, has been really the champion of this. He is our Chief Communication Officer. And I think we've had so many great partnerships with artists. And every day walking into this building on this, in beautiful coastal Maine, that is inspiring in and of itself. But then to walk by such amazing art that changes periodically, I just can't overemphasize how important it is for the science. And watching, I noticed Chris Ann Baker was here, and she had a wonderful installation that kids would just love. So I know many of you people have seen that while you visited previously. We work with things you can't see. And so if artists can help us show the amazing organisms that we work with in different ways, then we can. We're so grateful for that. So we're going to start off with our first partnership, artist Michel Droge. and Dr. Beth Orcutt. And I also want to say thank you to Beth because she is stepping up as our new interim Vice President for Research. And many of you know Beth, and we are thrilled to have her.
All right. Wow, look at all of these people, and hi everybody online. What a great pleasure to get to talk with you today about how I, as a scientist, get to work with an amazing artist and think about new ways that my science can be communicated and how art is an integral part of that. So in case you don't know me, I study life in the deep sea. And it's very hard to see even here on the screen behind us. It's a little bit dark, but what you're seeing there is a little robot shining a light on the seafloor, looking at some of the deep sea sponges and deep sea corals. And as part of my motivation in this collaboration, Michael and I have been talking a lot about how art can inspire people to care about this place that almost no one can get to see. So why should you here in the audience care about the deep sea? I want to tell you some fun facts about the deep sea. It covers more than half of Earth's solid surface. So if we want to understand how Earth works, probably need to understand the deep sea. You may not know that most of the microbes on our planet are in the deep sea or below the seafloor. Also, if you imagine all the life out in the ocean, it doesn't all have to be in the deep sea, but it's hard to get to. That's where most of our animal life on Earth is. So if we want to understand life on our planet, we need to understand the deep sea and the seas and oceans far away from land. When we go on these journeys to the deep sea, we're continually finding new species. And a lot of them are really weird, like maybe relatives of the earliest organisms on the planet. So again, if we want to understand life on our planet, we need to understand the deep sea. But there's a problem, and that is that most of us here on this planet, we don't have a connection with the deep sea, with this huge part of our Earth. More people have been to the moon, to the deepest part of the sea. This number should be 22 right now. Yesterday, Dr. Dawn Wright got to do a dive to the deep sea, the first African-American woman to go to the bottom of the ocean. But still, more people have been off of this planet than to the biggest part of our Earth. And this is important, not only because it's inspiring and amazing, but because there are new industries emerging that could irrevocably harm this environment. And one of them that I'm studying is this industry called deep sea mining. And as of right now, there is no evidence that if we were to mine, that those ecosystems could recover in human lifetimes. So I just want to tell you a little bit about what deep sea mining is. This is kind of a conceptual idea here, but imagine a giant vacuum cleaner that would be like the size of where I'm standing here, that would go along the floor of the ocean and pick up rocks. Why? Rocks have a lot of metals in them. And some of the important ones are nickel and cobalt, manganese and copper. These metals are needed for our transition to a fossil-free future. They're needed for the lithium-ion batteries in our cars, in our cell phones. They're needed for the really high-intensity magnets that go into windmills. They're needed for the active centers of photovoltaics for solar power. So it's a big part. We need these metals as consumers. And there's an interest in maybe getting them from the deep sea. That activity could cause harm to our oceans. So this is, again, a conceptual idea of a ship out in the ocean. It would maybe be disturbing the seafloor, the water column, all the animals that live there. And so this is a topic that I really care about and that my science informs. But how do I get people to care about this place that they will most likely never, ever get to see with their own eyes, unlike other planets, right, which we can see with telescopes and other things. So is art a way that I, as a scientist, can try to raise awareness and get people to care about this place? And I am so thankful that Michael reached out to Bigelow and expressed an interest in this topic, and that Stephen connected us together. And so we started meeting during the pandemic, virtual little chit chats. And I would talk about what I see in the deep sea, which are all kinds of weird animals, larvaceans, anemones, sponges, tube worms, octopus, and hear how these animals and what Michael was seeing inspired the work that they do. And so I'm going to now hand it over to Michael to talk about some of the work.
Thanks. Thank you, Beth. I guess, yeah, these are some of the images of things that I look at with Beth to get inspiration. And this one on the top left is from a video that's one of the first videos that Beth ever showed me. And I was blown away. It was last May of 2021 when we first started working together. Yeah, so I reached out to Bigelow because all of my work is focused on the environment and our integration with the environment, not like human beings are separate from the environment, but we're all part of it. And I heard that Bigelow was working with artists, so I reached out, and Stephen paired me with Beth. And what he said to me was, well, I have a scientist you can work with, but what she studies, you can't see. And I had not very long before mentioned to another artist in my studio who said to me, well, what are you trying to paint? And I said, well, I'm trying to paint what we can't see. So the whole thing just matched up, and I was like interested in this conversation. And as I met with Beth, she started talking to me about deep sea mining and the impacts on our ecosystems. And I started researching that alongside her and understanding what potentially this could do and the harm that it could cause. And I wanted to help bring this information to people in our communities so that we could raise awareness. And by pairing with scientists, we get a whole different kind of audience. Never spoken at Bigelow Labs before, and never shared my work then. I don't know if Beth had ever spoken at a gallery, but we did two together now and plan to do more of that. So we're already reaching more people, and we're going to be working with some universities, and we're hoping to just continue this collaboration. So without going on and on about all that, this is a painting called Galeen. And it is, it's hard to see some of the things in it on this slide, but it basically, Galeen is one of the Nereids, who's a daughter of Nereus and Doris, who's an Oceanid. And so this is all from Greek mythology. And Galeen means calm seas. So a lot of my titles of my paintings are based on Greek mythology, because I think it's interesting to weave those stories in as well. And so this is kind of a quiet painting. This one is called Piezophilic Heart, and in parentheses, Life in Extremes. And it's large, it's 68 inches high by 80 inches wide. So it fills a room pretty well. And I was looking at the hydrothermal vents and the creatures that live the creatures that live in these really hot, really high pressure areas. And so I find this like incredibly interesting, that these like temperatures of like 450 degrees Fahrenheit are like that's where lots of life is born and first seen. So I just think it's really amazing information and really beautiful. All the Light Below is another pretty large painting. It's 80 inches high by 68 wide. And I was really struck by the bioluminescence that I was seeing in all the videos and images that Beth was showing me. So, in the darkest part of the planet, right? Because there's no light down there. And I was struck by how much light is actually down there. And also the impact of having a submersible in these very, very dark places where they're not seeing light and shining a light in there, and sort of that relationship. I was also really struck by that. So that's where that painting came from. Periphery is a painting that is inspired. There's so many kinds of sponges, gorgeous, like all these beautiful lacy sponges. And it's another thing that we stand to lose from deep sea mining. So this painting was on the right, was inspired by that. On the left, Rift Zone is another fairly large painting, and it's inspired by the rift zone, which I mean is something a lot of people know about, but under the ocean, volcanic areas, there's all these different things happening. There's a lot of life happening there as well, and a lot of heat, and just like the emergence of life at the bottom of the sea, I think is really fascinating. And Riftia on the right was inspired by those sea worms that also grow right next to the hydrothermal vents. And they're like, some of them are like 6 feet large. I'm sure there's scientists in the audience who know more about this than I do, but I just found those like really gorgeous, amazing, like these huge stalks with these bright red like plumes, like I don't know, they're just gorgeous. So that's what that painting's about. And this one, Psychedelic Medusa, is an actual like nickname for a deep sea jellyfish that has this amazing bright red luminescence, and then has large like filaments for reaching out all around. Like I can't remember. Tentacles, yeah, that's what they're called. Anyway, and this painting is also has some like images of sea sponge kind of inspired pieces in there as well. And Subphotic Celebration is, you know, under the sea celebration, just also, you know, an Aegean, also just another piece inspired by these beautiful places. And is that it? Oh yeah. So going back, sorry, probably taking up too much time. So these are some drawings, and some of these are upstairs. There's like 4 of the 6 drawings that I made upstairs. And these are graphite on dendril. But right now, we're showing these because right now I'm working with Beth with some of the samples that Beth brought back from the deep sea, some manganese nodules, and I'm crushing them in the studio and turning them into paint, and using them as either paint or also as a substance like graphite to make drawings from. This is kind of the next iteration of the work that we're doing together. And I'm also working with Mike Lomas, who I'm not sure if he's here, but he's growing phytoplankton, which I'm also making paint from. And I just got this gorgeous like sap green from one of the samples that he gave me. So trying to like give the ocean a voice in another iteration, and bringing the material into the work and talking about what's there and what we have to lose, and also what we have to gain by taking care and being good stewards. I guess that's it. Yeah.
Yeah. Yeah. What a great collaboration. This is a growing collaboration. And I love that artwork can go on someone's wall and remind them about the deep sea, because they'll never put up a graph of my data. So this is great. So coming up next is our collaboration between Barney Balch and artist Julie Crane.
Thank you, Beth. Okay. I am a senior research scientist here at Bigelow, and I had the wonderful opportunity to work with Julie on this project. Part of this project was started with making a book. We've just published a book, and it's kind of a coffee table book that we produced as part of an NSF, National Science Foundation grant. This thing is available on Blurb, BLURB.com, and it's produced at cost. So anyhow, I'm going to show you some pictures of these organisms called coccolithophores, which I have spent most of my career studying, and then I'm going to pass it over to Julie. So first of all, just a little primer about what these microscopic plants are. They're unicellular algae that are covered with small micron-sized calcium carbonate or limestone plates called coccoliths. The first discovery that these things made massive blooms, and I'm talking blooms that cover entire ocean basins, the entire North Atlantic, or along the Southern Ocean, for example, was made in the 1980s by a gentleman who was actually a director here at Bigelow Laboratory, Patrick Holligan. The Gulf of Maine in 1988 was the site of my first encounter with one of these coccolithophore blooms. That one was about only 100,000 square kilometers. And the last thing I'm going to say about these organisms is that they connect entire subdisciplines of oceanography. They connect biology, chemistry, biogeochemistry, things that are settling into the deep sea, marine optics, they change the color of the ocean, geology, and paleontology. So this is my first date with destiny here. This is a coccolithophore bloom in the Gulf of Maine in June of 1988. And that line going across it was a cruise track that we took in a boat. We saw this thing from satellite. We had no idea what it was. We called up the agency and said, could we have a couple of bucks to get a ship to go out and see what it is? This is what it was. That's me down there in the corner on the side of the ship in a blue jacket. That's navy blue. But you can see how bright the water was. Here's a better picture of what the colors actually look like. The guy in the yellow jacket was Patrick Holligan. That's me with a little bit less gray hair. Looking at the Niskin bottle, but you see, it's like you ran aground in Bimini. That's what the water looks like. And if you filter that water, that's what you see. These were just loaded with these little calcium carbonate plates of coccolithophores that you're going to hear about a little bit more. And just so you think this isn't old information, here's a satellite overpass from 15 June 2022. And there is a bloom out there right now in about the same spot that we visited in 1988. So I'm just going to show you a couple of pictures. I put some comments up on the side, which are sayings that cross art and science. This first one here, which is called Helicosphaera pavimentum, it has that little scale bar is 1 micron, which is about 1/40th the diameter of a human hair. Look at the detail on these things. And Leo Tolstoy said, art is a microscope which the artist fixes. It's going too fast here, Stephen. There. Which the artist fixes on the secrets of his soul and shows to people these secrets which are common to all. Here's another one, Poricaliptra magnagii. And the quote I have for this one is by Antoine van Leeuwenhoek. In the year of 1657, now this guy invented the microscope, I discovered very small living creatures in rainwater. Here's another one, Syracusphera nodosa, very common coccolithophore. And Khalil Gibran said, the eye of a human being is a microscope, which makes the world seem bigger than it really is. Look at the detail on that thing. And there we go. This one is totally out. It's out there. This is by Roman Vishniak, who's a famous photographer and also biologist. Michael Sarzia elegans is the name of it. And it has these things called osteoliths, those things that look like connecting bones. And we think this thing is called a mixotroph. It lives on by digesting other organisms. And Vishniak said, nature, God, or whatever you want to call the creator of the universe, comes through the microscope clearly and strongly. Syracusphera mollischii, and just an amazing shot here, scanning electron micrograph. Nothing, I believe, is so full of life under the microscope as a drop of water from a stagnant pool, so said Agatha Christie. This did not come from a stagnant pool. Here's another one of these weird ones. Brigitte Lundy Payne said, I always imagine myself sitting on a ship, diving in, catching a fish, putting the fish under the microscope, looking at it, categorizing it, catching an alien, and saving the world. Well, this thing, Ophiaster formosus, and right on top is a little Emiliania huxleyi, also has these articulated osteoliths. No one really knows what these things are for. Allosphaera gaudii, just amazingly beautiful coccolithophore. Where the telescope ends, the microscope begins, and who can say which has the wider vision? Acanthoica quadraspina, another venture into the diversity of these organisms. People believe that art and science are two distinct realms. It's far from the truth, because if you look at science from a microscope or from a different lens, you can see the beauty in science. It's very artistic. This is a different life stage of coccolithophores. It's called a holococcolith, and a Syracusphera anthos. And the quote here by Theodore Roszak: nature composes some of her loveliest poems for the microscope. Let's see, finish that. Nature composes some of her loveliest poems for the microscope and the telescope. And there we go. And Victor Hugo: we see past time in a telescope and present time in a microscope, hence the apparent enormities of the present. And this is kind of poignant, given the James Webb Telescope is sending us our first images to see from outer space. Ophiaster formosus, another one of these really weird coccolithophores with the articulating osteoliths. Under the microscope, the little becomes larger to enlarge your life. Treasure the little things of life. And finally, I'm going to end here with Emiliania huxleyi. And unless you guys had a blindfold when you came into this building, you passed by a 6-foot diameter version of this. And I end with a quote by Carl Jung: I do not forget that my voice is but one voice, my experience a mere drop in the sea, my knowledge no greater than the visual field in a microscope. So now I'm going to hand it over to Julie, and what a pleasure it was to work with her as she made this sculpture outside.
Thank you, Barney. I'm going to read mine. Okay, so I do want to mention to start with that when I first approached Stephen, I was thinking I was going to try to do Discosphaera tubifera, which you did not show. And that one's very complicated, and I'm so glad that Barney likes Emiliania huxleyi. So this is for those of you that might want to try this at home. For starters, I would say you need to have a significant attraction to your object. I was just in love with Emiliania huxleyi, and it accompanied my thoughts during the day and in the middle of the night for months. Because we were traveling during the winter when this project started, I had to ship a lot of epoxy clay down to Florida. And that's where I began just doing these detailed inner sections of the shields for the Emiliania. When we got back, I had to ship them all back to Maine. I started doing those radiating spokes and the outer rims. And those were essentially, with this clay, it doesn't hold its own shape. So basically they were in these high density foam molds that I would make that I could change easily just by, sanding them or rasping them. So that process of making all of the shields began. And at the same time of that, the sphere was underway. Well, so that was made with fiberglass over a 4-foot, 8-inch vinyl ball. And thankfully, I have a husband who is a fiberglass composites expert. So there were, this would be done in hemispheres. So half of it would get a layer, and then a few days later it would get turned. And so, it was kind of, it took a long time to put about 6 or 7 layers of fiberglass on the sphere. We had to cut this sphere into quarters. So there needed to be a way to reinforce these seam lines. So all of that got built onto the outside of the sphere. You can see, this is just really a process shot of some of, what needed to happen to get things laid out correctly and in order.
After we made those reinforcing flanges, then the last layer on the sphere itself was this material called textilium, which is basically, what is it, aluminized coated fiberglass cloth. And the weave is called twill. And I love that. I loved it when the sphere was just wrapped in that textilium. It was in the depth of the shutdown with COVID when we were to the point of needing to coat it with this textilium. And thankfully, we had quite a bit of it, but not enough. And all of our people that could maybe resource some of this for us were coming up empty. I finally got 1 yard of it from this company that uses it when they make surfboards. So anyway, this was scary to me when the cut of the first quadrant came away. And oh, my time is up. So anyway, yeah, so that, so that was the beginning of the cutting it into 4 parts. And then here's a little glimpse of what it looked like to attach the flanges into it so that it would be reinforced. Oh, so yeah, in the meantime, I would be trying to let Stephen Profaser know that I was actually working on this project because it was taking a really long time. And so I would be trying to get ways for him to see the scale of it. And, I would bring the shields down to the beach or into the backyard. Here, let's see. Yeah, so there's some. It looked really natural to me in the water, even though it wasn't natural to the water. Here it is on the pond, the ice. So once everything was together, the armature had been built by Andy White. The sphere was back together, and then the shields were prepped for attachment. The process of placing the shields, which have 3 bolts, there's like a T-nut embedded into each shield, and then that gets bolted into the sphere. And it was really then tricky to realize how many of these shields were needed, because I had never had it on the sphere before. And there are different types of overlaps and different angles of position. So I was thinking I would need maybe 25 of them. They take about a week to make each. And, it was getting down to the home stretch and install date. And I ended up needing to make 31 of them. So it was high intense shield making at the end there. So this is an image of it installed here. I'm going to try to go a little quicker. And then look at this, and then this one. Oops! Oh gosh, it didn't. Well, okay. I guess this is how we're going to end. So this is I think this is supposed to have a. Oops. Okay, let's just see if there was another slide I thought after this one, but I think it's just going to go into this video. It's going to show you how fast and smoothly the install went. And I thought it was going to take about 6 hours, but you can see it was just really fast. There was some really good music to this. I called up the Mermen in Santa Cruz and asked them if I could use one of their songs called The Whales. It was the perfect accompaniment for this. Anyway, it was so fun to talk with this musician. There were 7 of us. thankfully. And everything went so smoothly and fast that we got it done in 3 hours. You can see we had a couple of keyholes in there at the end so that we could, reach around and attach the last couple. And I might kind of stop it. Ta-da. Okay.
Yeah, the next talk here is going to be by Anna Dibble and Lee Chisholm and Nick Record, senior science.
How would I start? Hi, everyone. So for those who don't know me, I'm Nick Record. I'm one of the senior scientists here as well. I've been here for about 9 years, and I've had the amazing opportunity to work with Anna and Lee and some other artists here over the years. Someone asked me today, how often does Bigelow work with artists? I was like, oh, it's kind of like at any given time, there are like 3 or 4 of these projects going on at once, which I just have to say I'm so lucky to be in a place like that. My science is ecosystem modeling, which is a little hard to explain, but it's basically the math of how all the pieces of the ecosystem fit together. So I work on everything from viruses to whales, and even to touch on what Michael said earlier, the people, how the people fit into the system. We're part of the ocean too. And so I'm at the nexus of a lot of collaborative projects. You could probably kind of see that, and maybe we'll talk about that a bit. I'm also a failed artist myself, and I use that word failure with the most reverence. Failing is one of my favorite things to do. So I really love these opportunities to work with artists, and I think with that, I don't have slides. Scientists love slides, but Lee and Anna convinced me that both art and science are processes of discovery. And so this talk is going to be a little bit like that as well. So I'll pass it off to Anna and Lee to go through their bit, and then we're just going to transition to a bit of a conversation after that.
Hi, I'm Anna Dibble, founding director of Gulf of Maine EcoArts. In 2018, I had a fairly wild idea to make a collaborative sculpture installation that was based on the fact that Gulf of Maine was warming faster than most of the oceans in the world, which I found to be a kind of an incredible statistic. The idea was to bring the ecosystem from under the waves, above the waves, to show people how we are connected with our neighbors in the sea, from plankton up through the whale. The sort of official theme of the project was changes in biodiversity due to human impact, climate change and human impact. And I had heard that Bigelow Lab liked to work with like to work with artists. And I came up here and talked to Stephen Profizer, who, it was amazing because I sat in the office up there and I just had this idea for a really giant sculpture installation. And I had no drawings, just these ideas and a lot of passion for it. And he looked at me and said, yeah, I think that we can do that, which was pretty amazing. And he talked to Deb Bronk and she got on board and we were able to move forward with the project. I put together a team of 7 environmental artists that were the collaborative decision-making team for the project. We worked with 16 schools. I can put the slide thing on now. It's not going on. Is it? Okay. Yeah, there we go. Okay. 16 schools from elementary level to college level. Worked with both science departments and art departments. One of the projects was what happened was we were working on this project in most of like 20. It started in 2018, so we were working on it for about a year, and right in the middle of it, a thing called a pandemic came along. It was, I remember the Ides of March in 2020, and all the schools closed down. So that really put a monkey wrench into what we were trying to do. And we had to pivot, as they say, and kind of reinvent ourselves and come up with some ways of doing the project that were different from the original planning. And this is a photograph of one of the best days during that time, because we were working with a teacher at Maine College of Art called Deb Began, who has an oceanography class there. And we went to Willard Beach and we did some green crab sculpture. And we got to the beach and there were all the students, we all had masks on. Everybody was in really bad moods because of the pandemic. It was early on. And that I was thinking, okay, there's no trash on the beach. Most had been cleaned up. There was just some stuff like seaweed around. And we kind of talked to them and they went out to do it. And it was a magical day because everybody just started making these green crabs out of all the stuff that they found. It was fantastic. So we began working on the project it was last summer was the very beginning of the construction of it. We had been planning it for a long time and working on other aspects of it with these 7 people. And this is Andy Rosen, who made the whale. And I met Andy. I had seen a really wonderful exhibit he'd done on the harbor in Portland of these wolves and wolf-like creatures. And I called him and he said he'd be interested in working with me, but he said he wanted to do a whale. So I said, okay, well, we'll have a whale and I want to do it life-size. So he designed a whale, which you can see down here, hanging here. And that summer, he and another guy, David Mahaney, worked on the project. Here's another picture of them. David's backyard, basically, and blue tarp over it so it wouldn't get wet. I'm gonna go back here. This is Joe Hemis, who is one of the artists, and he made the comb jellies that are hanging there. Comb jellies, Nick knows more about them, and he was very interested in them, and it was one of the reasons that Joe decided to do this. They're about this size, and I guess some are microscopic, maybe. But Joe did large versions of them. They all have lights in them. Oh, sorry. This is Joe's workshop. I thought it would be nice to include a slide of his wall of tools, which is sort of a work of art in itself. And that was one of the comb jellies before it came over here. And this is Pamela Moulton, who did what is called ghost gear that's hanging up there. And that's the sort of junk that gets human stuff that gets piled up on the ocean floor and then is brought to the surface. And it has a lot of microbial animals, I'm sure, living in it. And she was working on, we got a big shipment of nets from a donor of, these had all been down in Massachusetts and they weren't used anymore. And we sat there and she culled a lot of this net to make these and also future sculpture. And this was Lee Chisholm, who's here with me, who was another part of the artist team, and I made birds. These were mostly endangered and threatened birds. We worked in a process where it was a little difficult in the beginning to figure out what materials we'd end up with, but those were the final ones, which you can see hanging there. And here's the installation. We were able, despite the pandemic, to come in last September. It took us about a week to hang it. And this was the head of the whale that came in, and that was the first thing we hung in here. We had a couple lifts. There's Pamela's stuff going in. And there's somebody took a shot at night, which I've never seen, but looks pretty nice. And this is me and Nick, and I worked with Nick for the last almost 4 years now. We have had an ongoing conversation about the Gulf of Maine and the inhabitants. in it, and we are continuing to talk and work together. This part of the exhibit was based on Cash's Ledge, which is a unique underwater mountain range about 100 miles off the coast of Portland. And I'm going to talk a little bit more about that because once we hung this, less than 3 months later, thanks to Barbara Burgess, we were commissioned by the Maine Maritime Museum in Bath to do a much more kind of an immersive, experience-oriented installation. And we're working on that now. We've been working on it since January, and we're in full production now with a team of interns. And we will be hanging that in January. So you can come and see, these guys will move down there and they'll be reconfigured in a different space, and a bunch of other things will be added to it. And so now Lee Chisholm's going to talk a little bit more about that project.
Thank you, Anna. How much time do we have? I don't want to go on and on. Is there a timekeeper among us? Anybody?
You have 2 minutes.
2 minutes. All right. I am going to go right into a conversation with Nick because working with him in this project has been wonderful. Having him as an ally and the rest of Bigelow in the next project at Maine Maritime Museum is wonderful. And so I'm going to segue into it by mentioning that the college interns who we have working with us now on the Maine Maritime Museum installation were up here visiting this, and Nick met with them up there. And among other things, he said a lot of fascinating things. What we needed to do was get him talking, but one fascinating thing to me, anyway, that he said is, science is all about getting people to see the hitherto unseen. Isn't art somewhat the same way? And that set my wheels spinning. And I thought, for example, of Andy Rosen's whale. It looks for all the world like a skeleton, arguably. But he was working with his feeling, which I think is what the artist leads with, just as the scientist leads with their thinking. But the scientist needs the feeling and the artist needs the thinking, and the two combine. But Andy said, I want to do this huge whale. And it's going to go to the Maine Maritime Museum rather skeletally, but it's not a skeleton, He's got an invasive plant kind of weaving around its outside to show sort of the lines of force, the streaming water. And the motion of the thing, this beautiful S curve, is something living. And so it sort of hangs in the balance between here and gone. What could be more perfect for the state of the right whale right now? So I'm going to just hand this thing to Nick because I've used up 9/10 of the 2 minutes.
Thanks, Lee and Anna. I'm not sure what exactly the question was, but Lee and Anna and I have done a lot of these sort of ad-lib conversations, and I do like to talk about how art and science, both fundamentally show the world to people in ways that they haven't seen it before. That's something that they both have to do. And I could go on a little bit about that, but part of the idea here was that we're sort of ad-libbing, and both science and art discover things along the way when you don't have plans. Some of the best discoveries are made that way. So I thought I'd share an insight that has just come into my head just this evening, watching all of these talks, thinking about some of the human connections and the deep sea mining that Beth and Michael talked about. And then going through, listening to some of the quotes that Barney put up on the screen, I started thinking about, there's a lot of conversation now about what is science compared to other ways of knowing. We're talking about that a lot more. And of course, the question of what is art is something people have talked about since time immemorial. And so I started thinking about what is art? What have I been reading? And a quote popped into my head. Recently, I've been reading The Source of Self-Regard, which is a series of essays by Toni Morrison. She writes about art quite a lot. And one of the things she keeps coming back to is the best art is political. Otherwise you're just sort of propagating the status quo, to paraphrase in words much that fall short of the way that she can write and express things. And I was thinking about the Anna and Lee have pulled in the right whale and the marine debris as well in this. And, just thinking about, art that's political, that pushes us into spaces that we're uncomfortable. And asking myself, is that true of science too? Is the best science also political? And we're facing all of these existential crises now. And I see a lot of my colleagues sort of moving into this space and saying what is it that I'm studying? What is it, the knowledge that I'm getting? How is it pushing us outside of the status quo? And what is that? And I just see these really interesting parallels between the art that you're doing and the science that we're doing, and kind of the ways that these things are coming together. And so that's also just sort of my reflection on this evening. And every time I walk out of my office and leave my sort of little digital universe and walk around up there, I love being immersed in this sort of real space where I can see art and science and leaving the comfortable space. And I see Fritz signaling me that time's up. So I'll just leave you with that thought. The best art is political. You can take that for what it is. And thanks everyone. And we'll transition now to the musical segment of our performance.
Thank you all so much. My name is Sophie, and we are Halcyon. We're a string quartet based in Mid-Coast, Maine, and we are committed to using music to raise awareness of climate change and the opportunities and the challenges that we face here in Maine. So what you're about to see are 4 short vignettes that explore the shifting boundaries of Maine's shorelines and waterways in the face of climate change. And a lot of the information that you're going to see up here was actually published by Bigelow scientists, and I've spent a lot of time researching and brainstorming and really learning about the Gulf of Maine. So I can't thank Bigelow, Debbie, and Stephen enough for convening this. It's really, really an inspiring place to be. So tonight's program was created in partnership with Luke Fatora, who is a videographer and also a musician, and he's up there manning the controls. And together we researched and brainstormed and put together this program to try to communicate what we feel is incredibly important in terms of the changes, the opportunities, and the real challenge that we face as people living here in Maine. So thank you.
Okay, well, that's why we partner with artists, because they can deliver a gut punch on what's happening with this planet that all the data in the world can't do, because they can reach people in an emotional way. And I wish I had Kleenex, but I didn't think to bring any. Thank you so much for coming and spending this time with us. I think the partnerships we have with artists just really are incredibly helpful for the scientists to come in this building. Tell you, being a climate change scientist is not easy these days. And one of my jobs, I think, as CEO, is I'm supposed to be the chief cheerleader for this place. And again, it's not easy. So when you see something as beautiful as that, when you see Michel Droge's paintings and you walk in every day and you have just this whale looking at you, it really pumps us up. And it is a big shot in the arm to have so many people care and come out and spend this time with us. So thank you very much. I hope you will come and join us. This is the first of 4 cafe sizes here. I'll be giving a talk next week talking about, really, this is a defining decade for us in terms of making the changes we need to do to protect the environment that we rely on. And we're going to talk about the inspiration and the solution-oriented work that we do to take our discoveries and improve the world with them. We also, for those of you who are interested in coming back on Friday from 10 o'clock until 2 o'clock, we have an open house where we open up many of the labs. We'll have lots of activities. It's especially wonderful for kids because there's a lot of activities that can get them interested in science. And it's just a great day to kind of celebrate the work that we do here and show people why it's so important. So with that, I hope you will all stick around. We're going to have a reception in the back. You can talk to the artists. And I just want to give you my heartfelt thanks for joining us today and caring enough about coming out and hearing about what we're doing and the work that we're trying to do for the planet. Thanks so much.